Hello. In today's video, we will be going through Leetcode question 1 to sum. Now, this is a easy rated question, and it reads, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. So, essentially, we just need to find two numbers within this array, 2 and 7, which add up to target 9. Now, we also need to return their indices. So in this case, it would be 0 and 1. And that's the whole question. Now, the brute force way of doing this would be create a double for loop and check. Well, 2 and 7 are right there. Let's try a different case. Let's try 11 and 15. 11 plus 15 is 26. So we would have to loop through every single combination if we were to use this approach. So 2 plus 7 is 9, 2 plus 11 is 13, 2 plus 15 is 17. Not there, so we have to check with 7. Now we go 18, 22. Nope. And we have to check this, 26. Now, this does work, but it gives us a time complexity of O to the n squared. Not very ideal, especially if we were to use it on a larger sized array. So, instead, let's try a different approach. So the problem right now is we actually are able to go through this in O to the n by just iterating through every single number. And we do this by subtracting each number by the target, and here we get 24. Now, we check, is 24 in the array? No. So it's not the answer. 7, we go 26 minus 7 is equal to 19. 19 is also not in the array. 26 minus 11 is equal to 15. Oh, 15 is right here. So we know that the two numbers are 11 and 15. Now, the problem is we have to return their indices. And in this approach, we can keep track of the indice of 11 right here because we are going through it one by one. But the issue is this 15. This 15, in this case, is the next term, but it also could be 10 terms to the right. We don't know that, and there isn't an efficient way of doing this. Unless we use this other method. Now, if we were to keep track of the numbers that we've already gone over in some sort of memory as a hash map, we can actually store their indices as well as their values. So we would start with 2. And instead of, so we would do the exact same thing, 26 minus 2, which is equal to 24. And instead of comparing the 24 with the array, we're actually going to compare it with our memory instead. And that is because in our memory, we actually do have access to indices. So we see here is 24 in the array in the hash map. No. So we're actually going to store this 2 and its indice right next to it. See how we have the indice right here? So we actually do have access to it now. So the next number is 7. We go 26 minus 7 is equal to 19. 19 is not in the hash map. So we store 7 and its indice. We do the same thing with 11. Also not in the hash map. So we store this as well. Now we do 15. Now, notice 11 is actually in the hash map. And that means that we have found a combination that works for this case. So what we do is we use the indice of 15, which in this case is 0, 1, 2, 3. And the indice that we stored, 2. And that would be our solution. And since we are going through the array only one time instead of once for every single number, and so we are calling operations that are O to the 1 time complexity, this total algorithm would end up being O to the n, which is much better than O to the n squared. So, now that we are over in Leetcode, let's actually write this code. We're going to start by creating a hash map which keeps track of all the values that we go by. Let's just name it memory. Now we are going to go through every single value in this list, but we also want the index value, and in Python we can actually use the enumerate function, which allows us to keep track of the index that we're at. So now we need to calculate the difference, which is simply difference is equal to target minus num, and that is because target is always greater than num. So notice how when we were talking about the example earlier, we always stored the value first in the memory, and that is because now we are actually able to use this operation, check if the difference is in memory. You can only do this with the key values. If we were to set it as a value within the dictionary, we wouldn't be able to actually use it. If it was an item in the dictionary, we wouldn't be able to use it. So if this value was actually in memory, that means we've already gone past it. So we can actually just return I, which is the index of the number we're already at, and we actually want to return memory at difference. And this accesses the index value of difference within our memory hash map. This is only for the case where we actually do find the right number, but otherwise we actually want to store this within memory. We want to store this num, and we want to store its index. And since we are guaranteed to have a solution in this case, we don't need a return value at the end. And let's see if it works with our regular test cases. Yes, it does. Let's see if we can submit it. Yes, and as you can see, it's very quick. If we look at time complexity, we get O to the n, which is great. So thank you guys for watching. I'll see you in another video.